So if you look at the periodic table on the far right side, you'll see a column of elements beginning with fluorine. These are the halogens. They begin with fluorine, chlorine, bromine, iodine and astatine. And in order, they go down in reactivity and up in size. So fluorine and chlorine are gases, bromines are liquid, iodines are solid, and astatine is so rare, nobody knows what it looks like. It's estimated that any one time in the entire Earth there's about a gram of astatine that exists, because it's always breaking down and always being made, but in tiny, tiny amounts. The only astatine that's ever been studied has been synthesized in a laboratory, and it doesn't last. We're talking about 9 seconds or so before it's gone. So astatine's a pretty useless one as far as we're concerned, and fluorine, which is right at the top there, is a lightweight gas that is incredibly reactive. Now, oddly enough, when a halogen reacts, so fluorine reacts to become an ion, it's called the fluoride. Chlorine, chloride, bromine, bromide, iodine, iodide. The fluorine is really, really active, but the fluoride is incredibly unreactive, which is why you find it in things like Teflon. Chlorine actually is really common because we get it in table salt, sodium chloride. And it can be reacted relatively easily in both directions. Now, this isn't something that has escaped people, obviously, and with the drive to find batteries, which kind of mirrors what happened during the fuel crisis in the late 70s and 80s, Gulf Western looked at chlorine as a possible battery. So if we can get that to react with something in a reversible way that is incredibly cheap, we can have a really good but cheap battery, and that was their thinking, and it was good thinking. What they came up with was reacting it with zinc, because zinc is cheap and abundant and everywhere. So if we put zinc and chlorine together, we will get a zinc-chlorine battery. Now, chlorine, of course, is a poisonous gas that was used in the First World War to kill people by their millions. Now, Gulf and Western didn't let that stop them. What they discovered that is if you took the chlorine and put it in some water, brought the temperature down to 8 degrees centigrade, it formed a solid called chlorine hydrate, and that solid was incredibly stable. All you had to do was heat it up a little bit and it would give the chlorine gas back off in a nice controlled way, and you could flow that over some zinc, make zinc chloride and energy. As long as the system was sealed and you controlled those temperatures, you had a perfectly good battery. And Gulf and Western brought out several prototype vehicles with this, and they had a home generation system that they were suggesting. It, of course, died its death once the fuel crisis was over and people went back to petrol cars. Even though this is a technology from the 80s, it's by no means a dead technology. It's a technology that is under current investigation. Even Stanford have brought out a copy, although they're probably waiting until they get enough patents so they can publish on it. But everybody's looking at this because they're reviving that technology, because we're in exactly the same situation we were back in the 80s, and we just dumped it for 40 years and now it's being picked back up again. But here is the original 1980s explanation of how the Gulf and Western system worked. I did think about redoing the voiceover, but then I thought, just leave it, because they do a really good explanation, but you'll have to forgive the 80s bleepy music. But it's a good explanation of how that battery system works.
How the system works. Each unit consists of 2 chambers, a store, and a cell. Is totally sealed, and all parts requiring maintenance are on the outside. Each full-sized unit contains 60 cells holding 4,002 graphite plate electrodes. Half of these plates are alternately spaced zinc electrodes, and half are alternately spaced chlorine electrodes. Importantly, because the zinc chloride system has no active materials in its electrodes, it does not consume itself and deteriorate as do the lead acid and zinc nickel oxide systems. In a fully discharged unit, the electrolyte, a solution of water and zinc chloride salt, is held in the cell and the store. To charge the unit, a pump motor circulates the concentrated electrolyte from the store to the cell chamber. There, the zinc in the solution is attracted and deposited onto the zinc electrodes. The chlorine in the solution then escapes as a gas and is pumped into the store, where in mixture with water from the diluting electrolyte, it is chilled and forms frozen chlorine hydrate. This circulating process continues until all of the zinc is coated on the zinc graphite electrodes and all of the chlorine mixed with water is frozen in the store chamber. The remaining warm water from the electrolyte is held in the cell chamber. The entire process requires 6 to 8 hours for a 100% charge. To produce electricity, the warm water in the cell is pumped into the store, where it gradually melts the chlorine hydrate. This melted hydrate is circulated into the cell, where, as it passes through the graphite plate electrodes, the chlorine gas, which is like carbonated gas in soda water, is released from the hydrate and combines with the zinc on the zinc graphite electrodes. This coupling produces electricity at the system's terminals. Then the used coupled zinc chloride falls back into the circulating solution in the cell, reforming the zinc chloride electrolyte in ever-increasing concentrations until the chlorine hydrate has been completely melted. When this occurs, the system has delivered its full charge of electricity, and the electrolyte is once again a 100% concentrated solution.
Of course, there are not only chlorine batteries. You find bromine batteries and iodine batteries coupled with zinc. And if you want further information on the chlorine battery and on those other kind of batteries, your first step is going to be Google Scholar. Now, we will be covering the bromine and iodine batteries in different videos, but they can get a bit long if we try to do everything in one go, so there'll be other videos on those. What I wanted to draw your attention to was the zinc chlorine battery, which has great potential if you can get over your fear of being gassed to death, which is quite a fear to get over. But even so, it is a very active technology being looked at right now because, of course, we have the same problems today that they had back then. Anyway, I hope you enjoyed the video and thank you very much for watching. Please do remember to like and subscribe.